Okay, good day. This is Honors Algebra 2 Blended Learning Day for September 18th, 2023. The learning goals for today is going to be to solve rate, time, and distance linear application problems. And so the way I want to suggest that you do this, and there's no hard, fast rules, but if you follow these general steps, you should be okay. And the first thing you want to do is you're going to want to read the whole problem. And the variable is usually what the question is asking you to find, and it's often found in the last sentence. So what they ask you to find, that should be your variable. And then consider a verbal model and make a list of the unknown and known values. And so right off the bat, that variable that we found in the last sentence is going to be one of the unknown values, and then we'll go through the rest of the problem and try and assign values to the rest of the known values. We'll write an equation and then we'll solve. For all of these and all of the examples on your worksheet, we're going to use this distance equals velocity times the time. Now there are many variations of this, but they're all based on this. And remember, we can manipulate this. This is a multiplication. And so it shouldn't be too big of a stretch for me to say that velocity is equal to distance divided by time, and time would be equal to distance divided by velocity. And I can get those by just manipulating this equation. Let's go through a couple of examples and just kind of follow these steps. So our first example, it says Ming traveled to the recycling plant and back. It took 1 hour longer to go there than it did to come back. The average speed on the trip there was 20 kilometers per hour. The average speed on the way back was 25 kilometers per hour. How many hours did the trip there take? So right off the bat here, this first thing is the trip there is what I am looking for, and it is a time. All right, so now I'm going to go through and I'm going to try and fill in the blank with some of these other things. Ming traveled to the recycling plant and back. So right off there, since I'm going somewhere and coming back, the distance there is equal to the distance back. I know that I have an average speed on the trip there, so the velocity there was 20 kilometers per hour, and the velocity back was 25 kilometers per hour. So I know a lot of things. And then finally, I know that it took 1 hour longer to go there than it did to come back. All right, so the trip there, that what I'm looking for, is actually longer than it did to come back. So the time coming back was equal to the time going there minus 1. And that makes sense because he was faster on the way back. So let's use this distance equals velocity times time and say that since the distance there was equal to the distance back, then the velocity there times the time there should equal the velocity back times the time back. Now I'm going to fill in the blanks of what I know. I know that this was 20. I know that the time there is what I'm looking for. When I solve for that variable, I know that I'm finished. I know that the velocity back was 25, and I know that the time back was equal to the time there minus 1. And so now this just becomes a linear equation that I can solve fairly easily. This is 20t, and then I'm going to distribute at 25t there minus 25, and so here I will subtract 25t there, and that'll give me negative 5 times t there, because 20 minus 25 is negative 5, equals negative 5, divide by negative 5, divide by negative 5, and I get the time there to be equal to positive 5, and the units that they want, how many hours did the trip take? It It took 5 hours. All right, next example. Example number 2. Jimmy left school traveling towards the mountains 1.5 hours before Stephanie. Stephanie traveled in the opposite direction, going 12.9 kilometers slower than Jimmy for 2.5 hours, after which they were 289.5 kilometers apart. How fast did Jimmy travel? They tell us right off the bat that we are trying to find the velocity of Jimmy. Let's go through and start labeling some of the other values and try and figure out what we're trying to do. So Jimmy left the school traveling towards the mountains 1.5 hours before Stephanie, and then Stephanie traveled in the opposite direction, going 12.9 kilometers slower than Jimmy for 2.5 hours, after which they were that many miles apart. So let's start labeling time. So time for Jimmy, since he started 1.5 hours earlier than she did, and she traveled for 2.5 hours, then the time for Jimmy is a total of 4 hours. The time that Stephanie traveled would be just the 2.5 hours. The velocity that Stephanie traveled is the velocity that Jimmy traveled minus 12.9 kilometers per hour. Now, since they were going in opposite directions, and this was the total distance that they were apart, we're going to write it like that. We'll say that the distance that Jimmy traveled plus the distance that Stephanie traveled will be equal to 289.5 kilometers. So now I'll replace all these, the velocity of Jimmy times the time of Jimmy plus the velocity of Stephanie times the time of Stephanie, equaling to 289.5. So let's fill in what we need to know. This is the variable that we're looking for. We know that Jimmy traveled for 4 hours. We know that Stephanie traveled the same velocity as Jimmy minus 12.9 seconds, and she traveled for 2.5 hours, and they had a total of 289.5 kilometers. Now, I feel real good about this for the simple fact that even though we had a bunch of variables to start, we only have one variable left in this linear equation. So what we'll do is we will simplify a little bit. We usually don't write the number seconds, so 4 velocity of Jimmy, and then plus. So I'm going to distribute here this 2.5 to those two terms. So I'll have 2.5 times the velocity of Jimmy minus 2.5 times 12.9. Well, I've already done that, and I get negative 32.25 equaling to 289.5. All right, so here I'm going to collect my like terms. And I'll have 6.5 times the velocity of Jimmy and minus 32.25 equaling to 289.5. And then we will add 32.25. That'll give me 6.5 times the velocity of Jimmy, which is what I'm looking for, is equal to 321.75, and then we'll divide by 6.5. And again, I've already worked that out. So my velocity for Jimmy ends up being 49.5 kilometers per hour. All right, last example. Read through the whole thing. Cody left the movie theater and traveled toward the lake at an average speed of 30.5 miles per hour. Aaliyah left 0.9 hours later and traveled in the same direction, but with an average speed of 48.8 miles per hour. Find the number of hours Cody traveled before Aaliyah caught up. So right off the bat, find the number of hours Cody traveled before Aaliyah caught up. So we're trying to find the time for Cody. Let's go through and figure out some of these things. Cody left the movie theater at an average speed of 30.5 miles per hour. So my velocity for Cody was 30.5. And then let's see here, my velocity for Aaliyah was 48.8. And let's see here, the time for Aaliyah, she left after. So since we're finding the time for Cody, she traveled for 0.9 hours less than what he did. So it's the time that Cody traveled minus 0.9. And since they're asking how long it takes to catch up, the distance that Cody traveled is the same as the distance that Aaliyah traveled. And so what we'll do is we will do the velocity that Cody traveled times the time that Cody traveled is equal to the velocity that Aaliyah traveled times the time that Aaliyah traveled. I'll plug in what I know. I know that Cody traveled at 30.5 kilometers per hour, and we're trying to find that time. That's what we're trying to find. And so Aaliyah traveled 48.8 times the time Cody traveled minus 0.9. And so now I'm just going to distribute again. So I've got 30.5 times the time that Cody traveled is equal to 48.8 times the time that Cody traveled. And then I have to distribute this 48.8 times this 0.9. I've done that on a separate sheet of paper, and that comes out to be 43.92. And so here I distributed, and then here I am going to subtract 48.8, the time that Cody travels. That will give me negative 18.3 t of what Cody traveled, that's a decimal place right there, is equal to negative 43.92. Then I'm going to divide by this value over here. So divide by negative 18.3, and that will give me a final time for Cody as 2.4 hours. All right, that's all I got for today, folks. Have a good day. If you need any help, come to the office hours. Have a good day. Goodbye.